Hello everyone. Today my group mates and I will tell you about our group project. It is about our water rocket. In this video, we are going to talk about how to measure heights and how we made our water rockets fly to the highest altitude. First, let's start with explaining how to measure heights. Refer to the diagram here. We assume that the length of your arm is AD and the distance between you and the tree is DE. So, the length of the stick is BD. We observe that ADE is a straight line and both the stick and the tree are perpendicular to ADE. Then, we can easily find out triangle ABD is similar to triangle ACE. By the law of corresponding sides of similar triangles, ratio of corresponding sides are equal. AD over AE is equal to BD over CE. After knowing how this method works, we can simply measure the different distances and the length of the stick to find how tall is the tree. Next, we are using ratios to calculate the altitude of a flying object. But how? First, we have to take a photo with a person and the flying object. A diagram should be drawn on the photo as shown here. We have to know the ratio of the height of the person in the photo to his actual height. After that, we can use this ratio to calculate the altitude of the eagle in the figure. Let's assume that the ratio is 1 to 60. If the distance between the eagle and the ground in the photo is 5 centimeters, that means that its actual altitude is 3 meters. From the previous part, by shooting a photo, we can estimate the height of a flying object. However, if the speed of a moving object is very fast, such as a water rocket, then it is not easy to take a photo to achieve the estimation purpose. It is also difficult to measure the height accurately and effectively. There is a method an ordinary person can think of, and a scientific method to solve this problem. Firstly, we can record the whole scene of rocket launch and observe the highest point the rocket flies to in the recording. Then, we can use the ratio of the height of the rocket pump to its height in this part of the video to find the solution. Without using the camera method, we can still find out the maximum height using a mathematical method. Refer to the equation shown. The formula can help us find out what we want in this case. VO is the initial velocity of the rocket, and theta is the angle between the rocket and the ground. G is the acceleration of gravity, which is approximately 9.8 meters per second. Assume that the initial velocity of the rocket is 20 meters per second, and the angle to the ground is 87 degrees. Put the information into the formula. 20 squared times sine squared 87 degrees over 2 times 9.8. Then, we will find out the maximum height in this case is 20.4 meters, correct to 3 significant figures. Let me give you a brief introduction to water rockets. A water rocket is a type of model rocket using water as its reaction mass. The water is forced out by a pressurized gas, typically compressed air. Like all rocket engines, it operates on the principle of Newton's third law of motion, action and reaction forces. Water rockets are basically an upside-down fizzy drink bottle, which has a nose cone and some fins added to it. Refer to the diagram. The job of the nose cone is to make the rather snub-nosed end of fizzy drinks bottle more aerodynamic, reducing the resisting force of air acting on the rocket. Technically, the fins are important to ensure that the rocket flies smoothly. They handle the flying stance of the rocket, maintaining its stability. Without the fin and the nose cone, the orientation of the rocket would end in failure and cannot function properly. Every experiment requires a hypothesis. Therefore, we planned what to investigate before the launch of the water rocket. We aimed to explore the reality of gravity, Newton's second and third law, as well as the mass-energy equivalence. We assumed that the water rocket functions due to these laws. The hypothesis led us to the prototypes. With the assistance of a software called GoSpaces, we made 3 prototypes in total, which are the round-topped one with 4 nozzles, a standard rocket figure one, and a 4-bladed rocket. We had to decide on which prototype we should use, and we chose the second one. Not only does it have 3 propellers at the back, it also has a better aerodynamic, which allows it to shoot speedily and in a straight line during launch. After deciding which prototype we accepted, we continued by designing our experiment. We made the experiment panel as shown here. There's a ruler software to calculate the altitude, a stopwatch, as well as 3 models of water rockets. We planned our variable table. The independent variable is the model of the rocket we proposed. The dependent variable is the time the rocket model stays in the air as well as its highest altitude. The controlled variables include the angle of the rocket to the ground, the initial altitude, which tends to be 0 meters, and the amount of water, and so on. The following is our procedures for launching the water rocket. The first step is unquestionably designing and building our water rocket. We have to adjust the size and the shape of the rocket to fit. Next, we have to increase the air pressure in the rocket after 1/3 of water is poured into the water bottle of the rocket. After that, we can release the rocket from the pump. Cameras should be set up from the front view and side view to record the whole process. Finally, we can calculate our results and make a conclusion. It's time to answer the follow-up questions in this video. We can simply measure the maximum flight altitude using the camera method or the equation as mentioned in the early part of the video. As for how to measure the time for the longest stay in the air of our water rockets, we can use 3 stopwatches for separate timing of their launch. After introducing the previous methods and hypotheses, it is a time for us to list our required materials and equipment. As shown here, the bottle, cardboard, wood piece are required materials we need to build up our rocket. We also need a navigator, such as a heavy coin, for orientation to ensure that the water rocket travels in a straight line. Before the launch of the water rocket, we need water and the water pump to get the job done. In this video, we have introduced measuring methods and designing process of our project. Those methods may be helpful for us to find out the maximum altitude of the rocket's flying process. Besides, consulting from the internet helps us better design our water rocket, making it more streamlined and aerodynamic, and ensuring the flying track will be a certain straight line by adding fins on the surface. After giving out different hypotheses and experiments, we believe that our design will be performing well in the real flight, getting a satisfying result. We hope you can comprehend our plans and ways of measuring. The video ends here. I hope you liked it, and thanks for watching.